Hi class, my name is Jeff, and this is my presentation, Caffeine Dependence and its Physiological Impact on the Body. Some key points we will go over. Caffeine is a central nervous system stimulant, mechanism of action, and regular caffeine intake over time can lead to dependence. Caffeine is the most widely consumed psychoactive substance. It's found naturally in coffee, tea, chocolate, and is also added to many energy drinks. As a central nervous system psychostimulant, caffeine enhances alertness, reduces feelings of fatigue, and improves mental focus. It does this primarily by blocking adenosine receptors in the brain, preventing adenosine, the chemical that makes us feel sleepy, from binding and slowing down nerve activity. Here in the image, you can see the molecular structure of caffeine. Caffeine is made up of carbon, hydrogen, nitrogen, and oxygen atoms arranged into a structure called a xanthine backbone. The three CH3 groups you see attached to the rings are methyl groups, and they play an important role in how caffeine fits perfectly into adenosine receptors, allowing it to block them so effectively. So caffeine's primary mechanism of action involves its effects on the adenosine receptors found throughout the brain. Now, what exactly is adenosine? Adenosine is a naturally occurring molecule that acts as a neuromodulator. It's produced by our cells as a byproduct of energy use. As adenosine levels build up during the day, it binds to specific receptors in the brain. This binding promotes sleepiness, reduces arousal, and slows down nerve activity, which are all natural processes that prepare our bodies for rest. Caffeine's structure is similar enough to adenosine that it can fit into those same receptors, but instead of activating them, caffeine simply blocks them. It's what we call an antagonist. Importantly, caffeine blocks all four adenosine receptor subtypes. These are known as A1, A2A, A2B, and A3 receptors. However, the most important effects of wakefulness come from blocking A1 and A2A receptors. A1 receptors are widely found in areas like the cerebral cortex and hippocampus, where they normally inhibit nerve activity. Blocking A1 receptors help promote wakefulness, improve memory, and better reaction times. A2A receptors, meanwhile, are concentrated in regions like the basal ganglia, which are involved in mood regulation and motor control. By blocking A2A receptors, caffeine not only helps us stay awake, but can also enhance mood and physical performance. A2B and A3 receptors are less involved in the typical stimulant effects of caffeine and usually only become significant at very high doses. Overall, by blocking adenosine's natural actions at these receptors, caffeine promotes arousal, increases cognitive function, and delays the feeling of fatigue, allowing us to stay awake, alert, focused for longer periods of time. Regular caffeine consumption over time can lead to dependence. One of the major reasons for this is how the brain adapts to the constant presence of caffeine. Normally, adenosine binds to its receptors and promotes sleepiness. But when caffeine constantly blocks these receptors, the brain responds by increasing the number of adenosine receptors, a process called receptor upregulation. As a result, over time, people develop tolerance to caffeine, meaning they need higher and higher doses to feel the same level of alertness and energy. If someone suddenly stops consuming caffeine, the extra adenosine receptors make the brain much more sensitive to natural adenosine. This leads to classic withdrawal symptoms, such as headaches, fatigue, irritability, and trouble concentrating. A 2024 cross-sectional study conducted by Abdali and colleagues explored caffeine consumption patterns and related health effects in Iran. The researchers found that over 95% of participants consumed at least one caffeinated product the previous day. About 19.5% of adults met the criteria for caffeine use disorder, and 46.6 reported experiencing withdrawal symptoms like headaches, irritability, and fatigue when they reduced or missed their caffeine intake. 12.9% of individuals showed signs of both dependence and withdrawal symptoms at the same time. The most commonly reported problems were difficulty sleeping, craving sugary foods, and feeling like they needed caffeine just to function normally. These findings highlight that while caffeine is widely used and socially accepted, it can still lead to dependence and uncomfortable withdrawal symptoms when used heavily over time. If you feel like you're relying too much on caffeine, there are simple ways to take control. Gradually tapering your intake over 1 to 2 weeks can help reduce withdrawal symptoms. Switching to lower caffeine options like tea or decaf coffee, staying hydrated, and getting extra rest can also ease the transition. Tracking your caffeine consumption and keeping it under 400 milligrams per day is a good goal. Taking short breaks from caffeine now and then can also help reset your sensitivity and keep it working effectively. In conclusion, caffeine offers real benefits when used wisely, but regular heavy use can lead to dependence and withdrawal. Understanding how caffeine works on the brain and knowing how to manage your intake empowers you to use it as a tool and not a trap. Alright, so here are my references, and thank you for your time.